So this is tutorial designing a garden path using VBA XDX. This tutorial demonstrates the fundamentals of using ActiveX and Visual Basics for application VBA, and create a macro for use in the AutoCAD drawing environment. Audience, the tutorial is oriented toward landscape architecture, but the concepts in tutorial are relevant to any industry. Prerequisites for this: proficient with AutoCAD, novice VBA programmer, installation of the VBA idle. So checking your environment. That is the first one, checking your environment. The AutoCAD VBA Integrated Development Environment VBA IDE needs to be installed to create and execute macros. The VBA IDE is not installed with the product. It must be downloaded and installed separately. The following steps outline how to check for and install the VBA IDE as needed. At the AutoCAD command prompt, you enter VBA IDE. So if VBA IDE open, the VBA IDE is installed. If you receive VBA not installed, the VBA is not installed, and you proceed to step 2 to install VBA IDE. On the VBA not installed message box, click on that, open a web browser and browse to the URL. Close the message box, then close AutoCAD before proceeding. Close that, then close AutoCAD, no saving. On the web page, you download the appropriate module for the AutoCAD release and platform install on your workstation. Run the installer and follow the instructions that are displayed, and launch AutoCAD. And at the AutoCAD command prompt, enter VBA IDE, and the VBA IDE should open. So I'm gonna go there because I'm using 2021. I'm gonna download this. So I'm gonna just put in the download, setup, AutoCAD, add-in. It's gonna be AutoCAD VBA, and put in there 2012 as well and 2009 as well. Make sure that you have both. That's it. Don't download too much, it's very heavy. And let's see, I'm gonna close this and I'm gonna open. It will take a while, I think so. Really, new tab there. Okay, so I'm gonna open the window and put it there, and I'm gonna know that inside there, set up VBA. First one should be finished. Run that and just put in that Autodesk. And yes, I'm gonna install it. Install in this computer. That location should be okay. It's interesting. Now you need to install this. Finish. And now you run AutoCAD and you start drawing. And now you put in VBA IDE, and it should start Visual Basic for application global. That's fantastic. You can put in a side there and even put it up there. Okay, and that's it for the first lesson, checking your environment, for tutorial designing a garden path using VBA ActiveX in AutoCAD. Tutorial designing a garden path using VBA ActiveX, AutoCAD 2021. Defining the goal of the garden path. So the goal of this tutorial is to develop a new macro named garden path that draws a garden path and fills the path with circular concrete tiles. Overview. The macro prompts the user for the following information. It will start point and end point to specify the center line of the garden path, half width of the garden path, radius of the circular files, and spacing between the tiles. Note that the half width of the path is being used rather than the full width because this is easier to visualize the half width from the center line of the path. So prompt the sequence. After the new macro has been defined and is executed, it will present the user with the following prompt sequence. specify start point of path, specify end point of path, specify half width of path, specify radius of tiles, specify spacing between tiles. And that's it for defining the goal of the garden path tutorial, designing a garden path using VBA. Part 3, writing the utility function. When writing a program, it is beneficial to write small logical subroutines that you can be repurposed for other programs. The garden path macro is defined using a series of primary and secondary utility functions and subroutines. Many of the objects added to a drawing require the input or manipulation of angular values. Angles in a drawing are stored in radians, and as a result, the methods in the AutoCAD.com library require angular values in radians. However, most users think in degrees and not in radians. So it is important to prompt the user for degrees and then handle the conversion to radians in the code. Converting degrees to radians. The following formula is used to convert degrees to radians. So decimal angle multiplied by divided by 180 multiplied by pi. In the following steps, you define a function named DTR that accepts an angular measurement in decimal degrees and returns it in radians. At the AutoCAD command prompt, you enter VBA IDE. In the VBA IDE, on the menu bar, click on View and Code window for this drawing module. In the code window, type in the following code. So you declare a constant double variable, constant pi, like that. So just type in like this one. So you declare a constant double variable. You convert an angular measurement in degrees to radius. Use this for equal to DTR 90. The function is DTR A as double, and DTR is A over 100 multiplied by pi, and you end the function. And you click File and Save Global. And in the Save dialog box, in the file name text box, enter garden path and specify a location for the project and click Save. So maybe you can put it in there. In Learn with me in in AutoCAD Developer Network in VBA AutoCAD garden path, and in there you can put in garden path DVB. Is that DVB? Garden path. Save it. Calculating the distance between 2 points. In the following step, you define a function named distance that accepts 2D, 2 3D points and return a double value, which is the calculated distance between the 2 3D points. The value returned can be helpful in determining the midpoint along with a given axis. In a code window, click after the end function statement of the DTR function and press enter twice. End function, enter twice, and type in the following code and save it. So that's done. Writing the utility function. So basically, let's have a look at the code again. Here you got declare a constant double variable, and then you convert an angular measurement in degree to radius. You use var is DTR 90, and you define a function called DTR A as double, and you put in DTR is A over 100D multiplied by pi, and you end the function. You can calculate distance between 2 points. You use var equal to distance, point 1 and point 2. Then the function distance, SP as variant, EP as variant, as double. So you got dimension X as double, dimension Y as double, and dimension Z as double. And you have X, Y, Z, and you have distance. is square of square, square root of square root. So this function will calculate distance between 2 points. So the distance is that 1 point is a source point, and 1 point, this is a start point, and this is end point, and the distance is defined as double. And here you got define x as double, define y as double, and define this as double. So in Visual Basic, you need to assign every function you use, every variable you use, every variable types you use. Not like Python, you don't need to assign it. So here you assign the value. So you got the first point, you got the first element, and end point, you get the first element. Similar to get the second element of that 2 point, you got the distance in different direction. After you got the distance in different direction, you will square it, and then after you square them, you add them all together. You square one more time, and then something interesting here. So you square x and y, then you get the square root of x and y, and you square it, and then you plus the z, and then finally you square it. So that's the formula to calculate the 3D distance. And that's it for writing the utility function, which is part 3 of tutorial designing a garden path using VBA. Part 4, declaring global variables. The subroutines of the garden path macro utilize several global variables. A global variable can be used to exchange a value between functions or store a value while the project is located in memory. The following step explain how to define the global variables that will be used by the garden path macro. In the code window, click after the constant pi is equal to 1 point statement and press enter twice. Same there. In the code window, click after that and type in the following code and save the project. So that we put private sp is 0 to 2 is double, endpoint 0 to 3 is double, half width is double, something. And that's it for part 4, declaring global variables. Section 5, defining the command prompt interaction and calculating values. So the GPusher subroutine prompts the user of information necessary to draw a garden path. In this subroutine, you use the user input methods of the utility object and calculate values used to create the geometry for the outside edges of the path. In a code window, click after the end function statement of the distance function and press enter twice. Type in the following code. You're gonna go to code window and the distance function here. Enter that. After the distance function, save the project. The following illustration show how the value within GPuser subroutine are obtained and calculated for the garden path. So here values obtained by GPuser. So this is the length, this is the P angle, this is the half width, this is the end point, this is a start point, this is details of tiles, this is T thread, which is a radius, and this is a distance between different tile. That's very clear. And that's it for part 5, defining the command prompt interaction and calculating values. Section 6, drawing the outline of the garden path. The outline of the path can be drawn using the location and half width of the path acquired with the GPuser subroutine. In this subroutine, the outline of the garden path is drawn based on the values obtained with the GPuser subroutine and store in the global variable defined earlier. In the code window, click after the end sub statement of the GP user subroutine and type in the following code. Just copy in. I'm so lazy, and save the project. And that's it for drawing the outline of garden paths. Because the Visual Basic code is very easy to read. It's not like, it's very easy to read. Not like Autolips is terribly painful. So that's it for the section 6. Draw the outline of the garden. Part 7. Drawing the tiles within the garden path. So the draw tiles and draw subroutines are used to draw and calculate the circular tiles for the path. Draw a row of circular tiles. The circular tiles are drawn at a given distance along the path specified by its first argument, and the row is offset perpendicular to the path by a distance specified by its second argument. Each circular tile is drawn within the outline of the garden path based on the values obtained with the GP user subroutine and stored in the global variable defined earlier. As each row of tiles is drawn, each successive row that is drawn is offset to cover more space and make a more pleasing arrangement. So in the code window, click on the end sub statement of the DrawOut subroutine and put in the following code. One, and save the project. Calculating the rows of circular tiles. The draw subroutine draw only a single row of circular tiles, but can be used with a while loop to repeatedly draw all the circular tile rows. Tiles in adjacent row form equivalential triangles and shown in the previous illustration. The edges of these triangles are equal to twice the tile radius plus the spacing between the tiles. Therefore, by trigonometry, the distance along the path between rows is the sine of 60 degrees multiplied by this quantity, and the offset for odd rows is the cosine of 60 degrees multiplied by this quantity. An if statement is used to force the offsetting of every other row. If the offset variable is equal to 0, set it to spacing between the center of tiles multiplied by the cosine of 60 degrees as explained earlier. If the offset variable is not equal to 0, set to 0. This alternates the offset of the rows as you want. In the code window, click at the end sub statement of row subroutine and press enter twice and put in the code and save the project. And that's it for drawing the tiles within the garden path, which is sage putting it all together. Writing small subroutines allow for them to be used as building blocks to define a macro which the user can execute. In the following steps, you create a macro named garden path. The macro executes the smaller subroutines that were previously defined as part of the garden path project, resulting in the creation of a garden path. In the code window, click after the end sub statement of the DrawTiles subroutine and press enter twice. Type the following code. Save the project. So that is it for putting it. 9. Executing the garden path macro. A public subroutine, also known as a macro, can be executed from the AutoCAD user interface. In the following steps, you will learn to execute and use the garden path macro from the AutoCAD user interface. In AutoCAD, click Manage tab, Application Menu, Run Macro, VBA macro. So AutoCAD here, and you go to application panel, manage tab, application panel, you will say run script, run VBA macro. Note you can execute the garden path macro using VBA run command at the command from minus VBA run. So you can do minus VBA run, okay, and put the macro name, but we'll run the macro there. Okay, so in as a, and at the macro name you enter that garden. Okay, so let's try it. That's VBA run. Now it should be minus VBA run, and then type in that. Macro is not found. Interesting. I'm gonna see that some macro name is from the beginning. Interesting. That's alright. I'm gonna run using VBA macro, and in the macro dialog box, select the drawing macro and click run. This is a macro. Click run. Specify start point path, second point, radius the time, input keyword. Okay, so it's different. I'm gonna run it again. Start the point, start the end point, specify the width. Width is just maybe 3, radius of tiles maybe 1, no, 1 is too big, 0.5, space between tiles 0.1. Okay, so that's working now. That's fantastic. It's beautiful, really. How can it make that beautiful? From start point to end point, and then draw all the stuff inside there. And you see the space is very neat and beautiful. And you know, of course, the last one is not very nice, but that's already good. And that's it. That's how to execute the garden path macro. VBA run, macro name, maybe check the macro name there. So it is garden path, which is I'm gonna check that one. Garden, okay. So it's gonna be garden path DBD garden path. Yeah, DBD. See drawing garden path. Not found. I think it should be just sit drawing garden path. Yep, that's gonna work. So that's the way it won't work. So I just want to show it again here. Here the path width probably 5, the radius is 1, the segment is 2, looks like that. But it seems that in Autolips it's more visual. You click here, and click here, and click here, and enter a GUI or a dialog box. But the code with Visual Basic is much easier. So I think I'm gonna go for VBA. And because if you know VBA, you can use in ArcGIS as well. There's a lot of things in ArcGIS now also running in VBA, and Excel as well if you want. Yep, very convenient between Excel and VBA to Excel. And I'm going to show this again here, how to run it. VBA run, and I'm going to choose this drawing garden path, and then put in the first point, the second point, the width of the garden 4, the radius is 1, or maybe the one is smaller, 0.75, and the spacing is very small, 0.1, and then you're gonna have a garden path looks like that, beautifully drawn. What happens if you do manually? It will take you forever to make this. So that's it for executing the garden path macro, which is part 9 of the tutorial designing a garden path using VBA.